Alright, so a little update on my project Enhanced RASS since last time out. So I've updated my README files quite a lot with the latest documentation, and I've added some diagrams as well, mermaid diagrams, to display the flow of how the system is actually working. So here first there's two MCP endpoints here, so MCP tools to be precise: add document and query the RASS service. So you would upload a document, it would be chunked, the chunks would be indexed. Once that's confirmed, and the embedding in indexing is complete, and you will get a successful response that your document has been added to the index. Then for the fun part, querying the document, you send an API call to the backend through the MCP server. There's an agentic planner that generates a search plan, similar queries that help it find the answer to the query that you actually posted. It embeds the query as well, the similar queries, and then it performs a hybrid search and returns the top results for vector and keyword search both, and then re-ranks them using a cross-encoder re-ranker. Then you get the re-ranked results with the sources back as the answer. So I tested it with a storybook, War of the Worlds, as a document, and it would index it, of course, but it wouldn't give very good answers. Like, this is one of the most basic answers that it should have been able to answer, but still it does need work, and it was frustrating. So to improve the architecture again, I came across two techniques: small to big retrieval and hide hypothetical document embed. So in small to big retrieval, you actually embed the smaller text, and this actually enhances the retrieval quality, and eventually, using the smaller text or the smaller chunks, retrieve the larger chunks, which have more semantic and contextual information that actually helps the model in generating the final answer. So this next one's pretty interesting. In hide, basically you generate hypothetical embeddings of what a ideal answer might look like to the query, and you create an embedding of that ideal answer as well, what the LLM thinks might be an ideal answer, and you use it alongside in your vector search to retrieve much more accurate answers. It essentially broadens your net of capturing similar or semantically correct chunks. And with these new techniques, I'm getting much better results, and actually the sources as well of how it was able to derive the answer that it did. However, it's not always that simple. As you can see, prompt engineering is still pretty important, and asking the right questions is as well. So there can still be some improvements made, and yeah, that's the goal in making those and making it more better.